Good day everyone. You are welcome to this series of shoreline change detection analysis. In the previous video, we have done about 2 videos now. The first one was Introduction to Shoreline Change Detection Analysis. The second one was how to download satellite image for shoreline change detection analysis. And this is the third lesson or video in the module. And this video is about shoreline extraction from satellite image. If you need the entire module, entire lesson, including all the videos, all the material used, and all the slides, kindly check the description box. You'll see the link to download everything. So today we are going into shoreline extraction from satellite image, and I promise you it's going to be interesting. However, I need to quickly take you through some fundamentals so that by the time we are doing the practical, you will be able to follow, and it is something you also can practice and demonstrate. I'll give you all the file is in the description box. You can download it. So previously I've mentioned to you the factors that affect shoreline change detection analysis, especially when you want to run the analysis, the factors you need to consider. I've done this in the previous video. However, I need to emphasize one of the most important things we are concerned about in this lesson, and permit me to use my mouse, is the issue of accuracy. Accuracy is very important to us, and that is why the method and every technique we are going to use here is based on accuracy. We want to achieve the highest level of accuracy. So in this video, we are going to use a technique called normalized difference water index. That will be our starting point. In the previous video, I've explained and I've established it to you. I said that the NDWI is calculated from satellite image as green minus near infrared all over green plus near infrared. So in this exercise, we are going to use Landsat 7 and Landsat 8, and this is the formula we are going to use to calculate NDWI. So in the previous video, I've shown you how to download the satellite image for this exercise, and the image is in the file that will be in the description box. So, and these are the years under consideration: year 2000, 2010, 2020, and 2025, and our location is Akwa Ibom in Nigeria. So these are the series of steps that we are going to follow to achieve this shoreline extraction from satellite image. The first one is to calculate the NDWI, and the second step is raster reclassification. The third step is vectorization. The fourth one is feature dissolve, and the fifth one is landmass extraction. Actually, under each of the steps, there may be some sub-step under some of these steps. So, and then we are going to have clipping, then polygon to line conversion, shoreline extraction, and shoreline simplification, also called line cleaning. And these are some of the software we are going to use. We are going to use QGIS, we are going to use ArcGIS. I promise that this thing is going to be easy and straightforward. I have made it very sequential and logical. So I promise you are going to get it. Let's get started. So I have my folder. I've created my working folder. All the material are in this folder, everything, and this is part of what will be in the description box for you to download, because every data used, the video, the slide, will be in this folder. So in this folder, I've put every data I'm going to use inside here, and all the works and files that will be generated during the course of this analysis will also be saved in this folder, so that you can open the project and see what I've done. So let's go. So as initially said, the first step is the NDWI calculation. So we are going to achieve this in QGIS. So let me open QGIS. So let me bring all the data we are going to use. Click on Add Raster Layer. So navigate to your folder. We are going to use all these satellite images. select all the satellite image and click on add. So the first thing to do is to calculate the NDWI. So for year 2000, we are going to use Landsat 7. Come to Raster. Raster. Open Raster calculator. And here we are. Recall the formula. The formula for NDWI using Landsat 7 is band 2 minus band 4 all over band 2 plus band 4. Come to this raster calculator expression and open brackets. So here is the satellite image for year 2000. Here is it. And the formula is band 2 minus band 4 all over band 2 plus band 4. So after you open the bracket, it will be band 2. Here is it. Minus band 4. Close the brackets. Then put your console here. Divided by open brackets band 2 plus band 4. Then specify your output folder. Here is it. So here we are going to call it 2000 NDWI. Click on save and click on OK. The process is running, calculating NDWI. Yes, it is done. This is NDWI for year 2000. Similarly, we are going to do this for year 2010, 2020, and 2025. Let's do it. Come back to Raster calculator. So put your console here, open brackets. Then for year 2010, we are going to use Landsat 7 as well. So this is the year 2010 here. So it's going to be band 2 minus band 4, which is this. Yes, band 4. Close the brackets. Put your console here, divided by open brackets band 2 plus band 4. Close the brackets. Then specify output location. So this one will be 2010 NDWI. Yes, 2010 NDWI. Click on save and click on OK. So the process is ongoing. Yes, it's done for year 2010. Then let's calculate for year 2020. Come back to Raster calculator. Then for year 2020, we are using Landsat 8, which is band 3 minus band 5 all over band 3 plus band 5. So open brackets for year 2020, band 3 minus band 5. Close the brackets, divided by open brackets band 3 plus band 5. Close the brackets. Then specify output file. So this one is going to be 2020 NDWI. Click on save and click on OK. Yes, year 2020 NDWI is done. Then the next and the last one is year 2025. And for year 2025, we are going to use Landsat 8. And recall, it is band 3 minus band 5 all over band 3 plus band 5. So come to Raster raster calculator, and here open brackets band 3 minus band 5, close the brackets, divided by open brackets band 3 plus band 5, close the brackets. So specify the output folder. This will be 2025 NDWI. Click on Save. Click on OK. Yes, it's done. So let me move this up. Yes, if you look at our results, you will realize that the NDWI is from negative to positive. Negative to positive. What this means is that all the negative value are the landmass area, while the positive value are the water bodies. So what we did essentially is, from the satellite image, we have been able to separate water from land. So that is essentially what this NDWI calculation does for us. So now we are going to move to ArcGIS to continue. However, before you move to ArcGIS, make sure you save this very project. Save it. Click on Save. And let's save it here as NDWI. So click on Save. We are done with NDWI. So we can now minimize this. So let's go to ArcGIS. Let's bring all the NDWI we have calculated into ArcGIS. Click on Add Data and navigate to the folder. We have the NDWI for year 2000, 2010, 2020, and 2025. Click on Add. Click Yes. Yes, all the NDWI for year 2000, 2010, 2020, and 2025 has been added. Now, let me show you something here. As I said earlier on, that the negative value represents the landmass, while the positive value represents water. To verify that, pick this identify icon. If I click here, this is water body and this is landmass. If I click here, you can see the value is positive. Then if I click here, you can see the value is negative. So here is negative, which represent landmass where there is no water, and also vegetation where there is no water essentially. And here water is represented by positive value. So now this is where the work starts from. If you go to our steps, we have done with NDWI calculation. The next step now is raster reclassification. So to do that, we are going to do it one after the other for each year. Come to Arc Toolbox, come to Spatial Analyst Tool, come to Reclass, and come to Reclassify. Click here and choose year 2000. Then click on Classify. Here, what we want to do is to separate land from water, because shoreline is the area or line separating landmass from water body. So in that case, we need only two classes, water and landmass. So choose two classes here. Now, how do we now do it? I've told you that negative value represent land, while the positive value represent water. So in that case, from this lowest value to 0 means landmass. So here we are going to put 0. Then the remaining one from 0 to the highest value represent water. So we only need these two classes. So after we have put 0 here, which means from all the negative to 0 should be separated from all the 0 to the highest value. Then click on OK. So you can see from minus 0.6 to 0 is the new value is 1. This one will represent land, while from 0 to 0.4 is 2. So the new value 2 will represent the water body. So let's save it. Let's name it reclass 2000. Let's put extension .tif and click on save. Click on OK. The process is ongoing. Yes, it's successful. You can see it accurately separates water from landmass. This is landmass, which is represented by 1, and this is water body represented by 2 below. So now we have done reclassification. If you look at our step, this is raster reclassification. Now it is time for vectorization, or convert the raster to polygon. The intention or the essence of doing conversion, we want to polygonize it so that it will be easier for us to extract shoreline from vector, because as it is now, extracting shoreline from raster will be extremely difficult for us. So let's extract from vector. That's the essence of vectorization. So to vectorize, come back to your Act Toolbox and come to Conversion Tool. This is Conversion Tools. Then come to from raster to polygon. So here it will be reclass 2000. Then the field is value. Navigate to your working folder. This is my working folder. So this one I'll call it 2000 poly. That is 2000 polygon. Remember that we are still working with year 2000, the first year. So click on save. Click on OK. Yes, it is done. It has been converted to polygon. Let me uncheck this. Now, if I open the attribute table of this polygon, let me open the attribute table. You will see that under Greek code, we have two. If I double click here, and 1. So we have this 1, which represents the landmass, are this, and the 2 represent water. So they've been converted to polygon. However, as it is, we have numerous vector features. So it will be confusing, and for us to achieve accurate result, we need to dissolve. So let me close this. The next step is, after vectorization, we need to do what we call feature dissolve. Minimize this. Recall the field we are going to use to dissolve. Open attribute table again. Is going to be this Greek code, the one that represents landmass and water. So let me close this. Come to geoprocessing and come to dissolve. Then the input feature is going to be 2000 poly. Then our output feature class, name it 2000 dissolve. Always put the year so that you will differentiate it from other years. Click on save. So the field we want to use to dissolve is the Greek code. Then click on OK. Yes, the dissolve is done. Let me uncheck this. This is 2000 dissolve. If I right click and open the attributes table, you will see that we now have the 1 and 2, that is the landmass and the water body. Now, this is the essence. If I right click again and come to properties, I can come to symbology and categories. So let me categorize using the Greek code and click on add value. Then click on OK. So you can see that in polygon form, I have the landmass and water body separated from each other. So, and now it is in polygon. So let's check our step. We have done feature dissolve. The next step is landmass extraction. That is all the area that is land. We want to extract it from water. So to do that, this is how to do it. Simplest way to do it is this. Come to this 2000 dissolve. Right click and open the attribute table. Recall that I told you that 1 represents landmass when we reclassify the other time. So just select the 1. So let me close this. Once you select that one, that is, you are selecting the landmass only. Then come back here, right click, come to data and export it. We want to export only landmass. We want to extract only landmass from it. Click on export data, navigate to your working folder, and this time name it 2000 landmass. Click on save and click on OK. Click on yes to add it to map. Yes, it is added. So I can clear selection and uncheck this. So you can see that only landmass now has been extracted from the feature. So we are moving gradually to where we are going. And recall, we are still in year 1, 2000. So the next step, let's check. After landmass extraction, we have to clip. So we are going to clipping. Now, if you look at here, this image covers a large coastal area. It's covered in Nigeria, it's covered Akwa Ibom, part of Rivers State, part of Calabar, and even part of Bayelsa. So it's a very large coastal area. So, and we can't deal with the whole of the area. So let's just select a specific shoreline or coastal area to deal with. To make it, you can select any area of your choice. So let's just select this coastal area. For the purpose of this exercise, select specific area, specific coastal area. Now that is the essence of doing clipping. So we want to clip out only the area of our interest. To make it easier for us, we need to specify which area we want to clip. And to do that, it's quite simple. Now let's verify something. If I right click here and click on properties, come to source, our coordinate system is projected coordinate system. We are working with UTM zone 32. Close it. Now to clip, we need to just create or specify our area of interest. So to do that, come to catalog, connect to your working folder, and my working folder is this. Right click here and create a layer to specify my study area. So right click and come to new, come to shapefile. So let's just call this area of interest, and it's going to be a polygon, and specify the same coordinate system, UTM zone 32 knots, and click on OK. Click OK. So it has been created. Now put it in editing mode. Right click and come to edit features. Click start editing. Now come to create feature. That area of interest, click on it. So I just want to draw a polygon or boundary to specify my area of interest. So I can click here. Click here and click here. Double click. So I just want to deal with this area. That's why I specify this area. So you can come to editor and stop editing. click yes to save the edits. So I can make it hollow and click on OK. So this is the area I'm dealing with. I've specified my interest now. So to clip, I want to clip this shoreline. This is the area I want to deal with. So the step is called clipping. Let's go ahead. To clip, come to geoprocessing. You will see clip. Click on clip, then click on input feature, and our feature we want to input is the 2000 landmass. Then clip feature will be our area of interest. Navigate to your working folder. Let's save it as 2000 clip. Yes, I always put the year so that it will not confuse me when I'm doing my final work. Then click on save and click on OK. Yes, it has clipped this area for me. I can now uncheck this landmass and also uncheck area of interest. Yes, however, it is a polygon and we know our end result must be a line, which is shoreline. So it is a polygon. That is what will take us to the next step. And the next step after clipping is polygon to line conversion. How do we convert polygon to line? Let me show you now. That's the next step. So to do that, open your Arc toolbox and this time around come to Data Management Tools. Then come to Features. Scroll down and come to Polygon to Line. Double click it. Then Input feature. That will be our 2000 clip. Then Output feature. Navigate to your working folder. Let's call this 2000 line. Always put the year to know where you are. Then click on Save and click on OK. Yes, it is done. Let me close this and uncheck this. Yes, you can see the polygon has been converted to line. And of course, you can verify if you right click here and open the properties. Come to source and here geometry type, you can see it is a line. So it has been converted to line. So you can also select to verify. Click on this selection tool. You see it is a line. You can see it's a line. However, as it is broken. It is broken. Yes, it's broken, and if you zoom in, you see a lot of dangling. So we need to do cleaning as well. But before cleaning, let's specify the extent of the shoreline we want to extract. So to do that, we need to just indicate the starting point and end point of how long of the shoreline we want to extract. So I think I have a point. Let me just bring in a point to indicate that the starting and end points. So let me put it here. I want to start from here to here. So I'm concerned about this shoreline. After putting points at the places where you want to extract or how long the shoreline you want to extract, like the point I put here, so you need to remove other parts so that you'll be able to concentrate on the extent you are dealing with. So to do that, I'll just put this line into editing mode. Right click, come to edit feature and start editing. So choose this selection tool and click here and remove it. So that process, let me tell you, the process is shoreline extraction. So that is we want to only extract the real shoreline. Recall that this part is part of a landmass, but we want to extract only shoreline. So to do that, as you have put it in editing mode and select this very part, just click on delete. You can see it has been deleted. So the real shoreline is here. This is the real shoreline. If I check this reclassify map, you can see that all this area are shoreline, but this one is landmass. That's the reason why I removed the line here, because it's not shoreline. It was just landmass, but because of the process we use, it was demarcated as line, but not actually a shoreline. So I've removed it. The shoreline are here. So I've achieved this shoreline extraction now. So let me uncheck this. So the next process is shoreline simplification or line cleaning. This is because if I zoom in very well, you will see a lot of dangling line. These dangling line are not actually error. They are some sandbar island, small islands at the parts that these dangling lines represent. You can see them here. So, but the major shoreline must be a straight line. So all these dangling, which represents sandbar, small islands, and the likes, we want to remove them. That is what we call line simplification or line cleaning. So to do that is simple. As you have put it in editing mode, what you need to do is to start from your starting point, from here. Starting point. So we can uncheck this one now, the start to end point. We can uncheck it. Then all the dangling points or dangling lines, you now choose this selection tool and click on it. You can see it has selected that dangling line. Then delete. Then you'll be moving around the line. Anywhere you see that dangling line, you remove. Like here, we have another dangling line here. Click to select and delete. So what we are doing line cleaning or line simplification. So that is how you are going to go through, trace the line so that all the dangling lines will be removed. Here, remove it. This one, remove it. So such that we have a perfect clean line representing our shoreline. That's the essence of this operation. You can see I've removed all the dangling lines from our line. Now we have a perfect line, a perfect shoreline. Remaining one here. Yes. Click on it and delete. So we have cleaned the shoreline. Now we have a clean shoreline, no dangling. So this method ensures accuracy because you are not tampering with editing, you are only directing the software to do it. This is more perfect than using digitization, because digitization there will be analyst error. So after you have done this, clean it. If you click on the major line, you see that the lines are broken. So the final step now is to merge all this line or dissolve all this line into one single layer. Because if I right click on the layer and open the attributes table, you will see that we have a lot of about 29 features. So we have to merge it into one. So the easiest way to do that, we are going to use the same process called dissolve. This feature dissolve to achieve that. So come back and clear the selection. So come to geoprocessing, click on dissolve. Then here is going to be the 2000 line that you have cleaned. Then navigate to your working folder. This one will now be the 2000 shoreline. Yes, this is the final result, 2000 shoreline. Click on save. And the field you want to use to dissolve, you can use any of these two, either left FID or right FID. let's use right FID and click on OK. So it has dissolved it. Click on close. Yes, this is our final result. This is our final result for 2000. Year 2000 shoreline. You can see. This is year 2000 shoreline. If I check the image, our NDWI, you can see year 2000 shoreline. This is where it was in year 2000 as we extracted from satellite image. So we have successfully extracted for the first year. It took me so long because I'm explaining and I'm doing a video also recording it. So when you are doing it, it's actually more faster. So we have extracted for the first year. We have to extract for year 2010 using the same process, extract for year 2020 and extract for year 2025. So I've successfully run all these steps for year 2000. So now the next year we start the process from here, running it from each of the year. So let's go to year 2010 and it's the same process. I may not be able to record it for the video because it will be too long, but the same step I've used for year 2000, you will repeat the same step for each of the year on the NDWI. So let me quickly extract the shoreline for the remaining year and show you. Yes, I've successfully extracted the shoreline for year 2025, 2020, 2010 and 2000, and I've given distinct color to each of the shoreline using the same method which I've shown you, the one I demonstrated using year 2000 shoreline. So I use the same method and I've extracted for other years. However, there is an observation here. If you look at that of 2025, the one in purple, 2025, it looks bloated, and this is because if you look, it's so different from others. Actually there was a change, no doubt about that, but the change looks so bloated, and this is because there was high level of cloud in the satellite image used. So the level of cloud affected the accuracy of this year 2025 shoreline extraction. So it's worthy of note is that the cloud in the satellite image you are using will affect the accuracy of your shoreline extraction. In overall, I've extracted using this method shoreline for this very particular area for year 2000, year 2010, year 2020 and year 2025, and you can see the variation. So guys, this is how to extract shoreline from satellite image. So you can just take your time and do it as well. So the files and everything is in the folder that is in the description box. So you can download everything and use it to practice. You'll find the reason why this year 2025 is particularly so different from others, and which I've explained. It was due to the level of cloud in that very particular satellite image. In the next video, we are going to be doing shoreline change detection analysis proper, and I hope to see you in that video. Thank you for watching.